So for a problem like this one, right, where we got, and I think we did, seems like we may have had an example like this with the lesson. What was this, 2.1 maybe? Maybe it's 2.2. But in any case, even if we didn't, that's okay. We can look at this one. One thing we'll want to do, especially with that x squared, just right now while we're trying to understand this, is I would probably want to show this as 2 times x, right? Instead of x to the power of 2, because sometimes we just kind of we're not used to seeing that exponent right now. So just seeing that as x times x may be helpful. And then when we multiply it by 5x, hopefully it will kind of help us to see what happens in the end on this. And so I would almost recommend kind of looking at that as 6 times x right there, and then the 4 even, right? We got the 4 right there. So we're going to take all of these terms and multiply them by this 5x out here in the front. So we're going to distribute that 5x into each of these. Let's start with a 2x times x. So if I had 2x, or 2 times x, and I multiply that by 5 times x, right? So this is all multiplication. So to simplify this, I'm going to multiply the two numbers, which is really just the commutative property of multiplication. 5 times 2 is 10. And then I've got x times x times x, right? Well, if I simplified that, I would show it as x to the power of 3. And then that term by itself would have been simplified with that distribution. And so it works the same way with the 5x times and again, I would say that's a negative 6x. So right here, the second term is 5 times x times what is negative 6 times x. So again, just by multiplying the two numbers, 5 times negative 6 makes the term negative 30, and then the x's, right? Well, I've got a base x. How many x's are being multiplied? 2 of them. So far this expression shows is 10 times x to the power of 3 minus 30 times x to the power of 2. And then, of course, finally just distribute the 5x to the 4. So again, I would be looking at that as 5 times x times 4. And again, 5 times 4 is 20, which is positive, so I'm going to show that as plus. And then, of course, we just got that x. And there was only one x, so, technically there is an exponent of 1 there. We're not worried about that right now. Just put the x. And that would be fully simplified. So I'm just going to read this out. For this project, you will apply algebraic equations to solve an everyday situation. I am considering purchasing the iPhone 6. And notice the following two options. So we got the option 1, pay $199 for the phone with AT&T, but then pay $80 a month under a 2-year contract, 2 gigabytes of data per month with possible overages. Option 2, pay $649 for the phone, but then pay $50 a month to T-Mobile. No contract, 1 gigabyte of data per month, no overages. Using the information above, answer the following questions. Considering the cost of both the phone and the monthly data plan, how much will the total cost of using each phone be after 1 month? Show all your work. We'll keep that information up there, and just so we understand when we're doing this, the gigabytes of data per month, that's not really important. We're not really concerned about either one of those, even the contract stuff, right? And maybe that would be important to you if you were purchasing it, but mathematically speaking, we're just looking at total costs. So for total costs, let's just look at AT&T, I guess, first. So you're going to start, let's see, with $199 for the phone, right? So $199 for the phone. And then $80 a month. So after 1 month, of course, you'd be paying that $80. And just add these two together. So you could add it this way if you'd like. So that's a 9, a 7, and then carry the 1 there. So after 1 month with AT&T, you're looking at $279. Now option 2, that was T-Mobile. By the way, this is not an endorsement for either one of these. It's just math, okay? So for T-Mobile, you're going to pay for the phone up front, $649. And then it's $50 a month. So we're going to add $50 for the 1 month. And then adding these two together, $699. How much would the total cost of each phone be after 3 months? All right, so again, just going through this. For AT&T, once again, we're going to pay the $199 for the phone, right? We already paid that. We don't need to pay for it 3 times. It's not like we're going to pay for the phone every month. So we got $199 there. And then we got the $80 per month. Now, if you wanted to, you could say, well, it's 3 months. I'm just going to add 80 to itself 3 times, right? But multiplication makes it a little bit shorter. So I'm just going to say it's 3 groups of 80. That's 3 months of $80. And then the $199 phone. So let's do the math here. 8 times 3, that'd be 24. Tacking on that 0. And then I'll add that to $199. So putting these together, we get 9. 4 plus 9 is 13. 1 plus 2 is 3. Carry the 1. So looks like that's $439. So that was AT&T. But then we got T-Mobile, which has the phone for $649. And then a $50 a month, I guess, plan. So we're going to add $50 a month for 3 months. So 3 groups of 50 would be $150. And again, that $150 right there is just for how much it costs to have the plan, right? That doesn't include the phone, which is what we need. So we're going to include the phone here. So 0 plus 9 is 9. 4 plus 5 is, sorry, that's a 9. 4 plus 5 is 9. And then 6 plus 1 is 7. So it looks like for T-Mobile, after 3 months, would have paid $799. Number 3, how much would the total cost of each phone be after 1 year? So this is 12 months, right? And again, for AT&T, we got the phone, which was $199. And then a plan, so we're going to add the monthly cost, which $80 for 12 months. So again, we'll go through the math there. 8 times 12, again, we're just going to tack the 0 onto whatever that is, would be $960. Then we need to add the $199. So let's see, 0 plus 9 is 9. 9 plus 6 is 15. 9 plus 1 is 10, but plus that 1 makes that 11. So $1,159 for AT&T after 12 months. So we'll do the same thing for T-Mobile. We got $649 phone, adding $50 a month for 12 months. So again, this 50 times 12 tells me how much it cost just in the monthly payments. 50 times 12, so again, just 0, but 5 times 12 is 60. So that's $600 for the 12 months. Add the $649. So 9 plus 0 is 9, 4 plus 0 is 4, 6 plus 6 is 12. And hopefully we can notice just by number 3 that T-Mobile's plan and AT&T's plan, they're getting closer together, right? The total cost for the 2 plans is getting closer together. Which means at some point, and this is a later question, at some point in time, T-Mobile's plan should be cheaper. And we'll figure that out when we get there. And number 4, after 2 years of use, how much will the total cost of the phones be? Now, one mistake we find on this reality check, it's not very common, but it just happens from time to time, is where we would take the cost after 1 year and just multiply it by 2. But the problem with that is that you would end up paying for the phone twice, which you shouldn't want to do, right? But again, that would be what would happen in the mistake of just multiplying 1 year by the 1 year total by 2. So again, we need to focus on what it's saying, right? We only want to pay for the phone once, so just keep that $199 there. And then it's $80 a month. Now 2 years, that's going to be 24 months. So we'll do the multiplication. 8 times 24, we'll show that there, because we're not using calculators technically yet. 8 times 4 is 32. 8 times 2 is 16, plus 3 is 19, right? So something seemed off about that, but that seems okay now. 192. I forgot to tack on that 0 right there. That's much better. So I got 199 plus that 1,920. And again, just by combining these, 9 plus 0 is 9. Tens place, 9 plus 2 is 11. The hundreds place, 9 plus 1 is 10, plus the 1 is 11. And then 1 plus 1 is 2. So looks like after 2 years for AT&T, you've paid $2,119. And then T-Mobile, again, the phone, you're only going to pay for it once, so $649 plus $50 a month for 24 months. So what do we got? We got 5 times 24. We'll show that there. And again, we'll just tack on the 0 to that. So 5 times 4 is 20. 5 times 2 is 10, plus 2 is 12. So 120 with that extra 0 makes that 1,200. Plus the 649 makes this $1,849. And we can see after 2 years of having T-Mobile's plan that it's become cheaper. Yeah, here we go. Number 5. Which plan is the least expensive after 2 full years of use, and by how much? Alright, so that was the answer that we just barely found, right? For number 4. And AT&T's plan is more expensive, so I'm just going to take it, that $2,119, and I'll subtract T-Mobile's plan. This will tell me how much more expensive it is. And T-Mobile was at $1,849. So doing this subtraction, I can see 9 minus 9 is 0. We'll have to borrow there. 11 minus 4 is going to be 7. 0 we'll have to borrow there. 10 minus 8 is 2. So it looks like it's $270. I guess AT&T would be considered $270 more expensive, or T-Mobile is $270 cheaper after 2 years of full use. And so, which plan was least expensive? Again, that was T-Mobile in this case. So it's a T-Mobile was cheaper by $270 after 2 full years of use. At what point in time are the plans equivalent? Alright, so for this one, an equation may be useful rather than just using kind of guess and test, right? We know after 2 years, after 24 months, that T-Mobile was cheaper, and after 12 months, AT&T was cheaper though, right? But if we can just write an equation for this one, then it hopefully would become pretty clear. So starting off, we had AT&T, right? And we know we're going to pay the $199 for the phone. But in addition to that, we're going to pay $80 a month. Now, right now, I'm just going to say X equals the number of months, because I don't know how many months it's going to take for the two plans to be equal. And this would just be a general equation for AT&T anyways right now. So X is going to be number of months. And we saw this pattern as we went through the first 4 questions, right? It was 199 plus 80 times the number of months. So this would be an equation for AT&T. For T-Mobile, you're going to pay that $649 and then $50 a month. So again, and we saw this pattern. It's 649 plus 50 times however many months it was. 1, 3, 12, and 24 is the 4 values we used. Now, this one's saying that the plans are equivalent, right? So we want to know when AT&T would be equal to T-Mobile. All right, so in other words, we want to know when these two equations are equal to each other. And remember, a lot of this class is just learning how to manipulate stuff to be what you want it to be. So instead of having the A there, A for AT&T, I'm just going to replace it with the equation that we found, which was $199 plus $80 a month. And that's for AT&T, right? And again, for T-Mobile, I'm going to replace that one with the equation we had for T-Mobile, which was $649 plus 50 times X. And if you used a different letter, like M for months, that's fine. It's going to be the same thing. So this becomes a multi-step equation, just solving for X. And once we do solve for X, again, X would be a solution to this equation, which means that it should make the equation a true statement. So whatever I get on the left should be the same thing on the right. And again, we're not looking for how much money it's going to cost, which we could figure out after we solve this. And that's what I would recommend after you check. After you've figured out how many months it is, just check. But we're just going to solve this as an equation. I'm going to put the x's on the left, so that 199 on the left there in black, I don't want it there. I need the x's on the left side of the equal sign. So I need to zero that out. So I'm going to subtract 199 from both sides of the equal sign. So that zeroes that out. That's what we wanted. And now we got 80x equals 649 minus 199. Let's see, what do we get out of that? 450. And then plus that 50x. So again, I chose to put the x's on the left, so that plus 50x there in purple, that's not really where that should be. I don't want any x's on the right side of the equals. So I need to zero that out as well, just subtract 50x. But again, if I do it to one side, by the principles of equality, I've got to do it to both sides. So that zeroes that out, and 80x's minus 50x's would be 30x's. And this should equal now 450. So the last thing we would do in this problem to solve it, sorry, I just need a little bit more space there, is to divide both sides of the equal sign by 30 to make that a 1x. Right, so 1 month, 450 divided by 30, you can cross the zeros out. So it's really just 45 divided by 3, and that's 15. Now, I'm going to emphasize this. The answer is not actually 15, okay? We did the math. We did really good math. And the reason why the answer is not 15 is because we need to remember to label answers like this, okay? So it's 15 months. And that would be the answer. Once this pulls up. So we got 450 divided by 30. Now, you don't have to know your multiplication tables of 30. You can just make a kind of a list of the multiples of 30, right? So the first multiple of 30 is, well, 30, right? And the second multiple, I'm just going to add another 30 there to make 60. That should have been a 30 there to make 60. And then add another 30 to make the third multiple 90. And we'll add another 30 there to make that 120. Now I need to get to, really, I guess, let me think how I want to say that, 3, you know, we could look at it like this as well, is how many times does 30 go into 45? Well, that's one time, right? So then I could take that and subtract 30 right there. And then I got 150 now, because I got to drop this 0 in the ones place. Because 30 doesn't go into 40, so I mean, there's a 0 there, but I'm not really worried about that 0. So I'm just looking at how many times does 30 go into 150, and whatever value I get from that, I'm going to put in the ones place value. So I can see it go, right now I've got a list up to 120. If I add another 30, so that was my fourth multiple there. Let me put that in. If I add another 30, then I get 150, which is what that is in purple. So 30 goes into 150, that was the 5th multiple on that one. So when I subtract that out, I get a 0 remainder. And that's why that answer right there is 15. Even if you didn't cancel out the zeros like I did.